Alright, so first thing, we have some definitions. And just like yesterday, I think I printed those slides with all these on here for you, so you're not trying to just memorize or copy them down. When I talk about mutually exclusive, so I will use the terms mutually exclusive and disjoint interchangeably. And it just means that there's no common outcomes. They don't have anything in common. You cannot be both. So it would be saying your 6th hour class is calculus and your 6th hour class is algebra 1. Can you be in both classes at one time? No. So those events are mutually exclusive. There is no overlap. No person could be in both sets at once. All right. Another way of saying that is the probability of both of them happening. If they can't both happen, what's your probability? 0. It's impossible for both of them to happen. All right. So that leads us into the addition rule. This is on your formula sheet. So we're going to have a couple different variations, but today we're specifically talking about with those disjoint sets. So the probability of one or the other happening, you just add their individual probabilities. If I want to take a random student in the high school and find the probability they are in 6th hour calculus or 6th hour algebra 1. Okay, you can't be in both, so I just add the calculus plus the algebra 1. Alright, there's no way that I double counted anyone. This is on your formula sheet. We did yesterday empirical and classical under chapter 5, so the second column, that first bullet there, the addition rule for disjoint events. So we're given that. So what we need to remember, or means we're adding probabilities. So if I want this or this, we are adding up the probabilities. So let's take a look at one. The probability model shows the distribution of the number of rooms and housing units in the United States. Part A, verify that it is a probability model. Yesterday I told you there are 2 requirements to be a probability model. What are they?
Between 0 and 1.
They have to add to 1 and everything has to be between 0 and 1. So those are the 2 things. So if I check, each probability is between 0 and 1. So we're good there. When you add them all up, does it equal 1? Yes. Okay. So we met both of our requirements for a probability model. Part B, what's the probability a randomly selected housing unit has 2 or 3 rooms? Can it have both 2 and 3? No. So all we have to do is the probability of 2, or means plus the probability of 3. So the probability of 2 is
0.032.
plus the probability of 3. Add those together. So about a 12.5% that we have either 2 or 3 rooms in our unit. Is that okay? Alright, so C. What's the probability that a randomly selected housing unit has 1 or 2 or 3? So I gave you 3 possibilities, so what do you think we have to do? Just add them up, because it can't be more than one of them. So we add the 1 plus the 2 plus the 3. Is that okay? Now, what if I said find the probability that a student is in calculus or statistics? Can I just add those probabilities together? What's wrong with that?
We'll have overlap.
Yeah, they're two different subjects, but do I have some of you in both classes? Yes. So if I just added up the number of students in calculus and the number of students in statistics, I would be double counting some people. So if those sets aren't disjoint, if somebody could be in both, when I want the probability of one or the other, we have to watch for those people that we're double counting. So the general addition rule is if these events are not disjoint, so if I'm thinking about, all right, here's E, here's F. If I add up E and I add up F, I've double counted these people in the middle. So I have to subtract off the overlap between the two. So if they are not just two separate sets, if we do have people that fit into both groups, for our probability, we add them up and subtract the ones we double counted. We subtract that overlap. So let's do some examples with this. Suppose a pair of dice are thrown. So I'm showing you every possible combination when I roll two dice, what I could get. Let E be the first dice is a 2, and F be the sum of the dice is less than or equal to 5. Find the probability of E or F. So I'm trying to find the probability that the first one is a 2 or they add up to something less than or equal to 5. Now in this case, could there be overlap? Could something be less than 2, the first one be less than 2, and they add up to something less than 5? Yeah, if I roll, for instance, like a 2 and a 1, or a 2 and a 2, or a 2 and a 3, we're going to double count. But in this case, we're looking at a picture. Can we just figure out how many of these options fit what we need? So if the first one is a 2, that would be all of those. The sum is less than or equal to 5. So let's figure out how many others we would need to add in. So 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4. I'd have to stop there. I already have all the second row, so I don't need to highlight any more of those. 3 plus 1, 3 plus 2, 4 plus 1, and is that it?
Yep.
Okay, so if I'm trying to find the probability of E or F, we could try to do the formula, but we can also just count here. So if I want, thinking about yesterday, how many different combinations were there? I think there's 36 combinations. There's 6 for the first, 6 for the second. So we have 36 different.
I was not making pairs.
Oh yeah, there's 72 dice. And then how many of those did I highlight?
13. Oh, I got the counting again. 13.
So 13 out of 36 gives me what?
0.36.
So in this case, did I really even have to use my probability formulas? No, we could find it like we were yesterday. And sometimes that's the easiest option, if I give you this picture. Let's try another one, where maybe we can't just look at a picture. We have to think through it and use our formulas. Suppose a single card is selected from a standard deck. Okay, do you guys know cards in here?
Mm-hmm.
How many cards are in a deck?
52.
52 cards. There are 4 different suits. Do you guys play cards? Some of you look like yes, some not so much. Each suit you have ace, king, queen, jack, all the way down to a 2, right? I want the probability of drawing a king or a diamond. Alright, so again, we might just be able to think about this. We can also think of it in terms of our formulas. Or means add, so I just need the probability of a king plus the probability of a diamond. Can you be both a king and a diamond? One time, so minus the probability of both. That's the general addition formula. The probability of E or F. It's probability of E plus probability of F minus the probability of both. Now, would you have to write it out using this formula? No. Just trying to give you different options for thinking about it. But the formulas will be handy as we get into more complicated probabilities. So, the probability of being a king. In my deck of 52 cards, how many kings are there? 4. The king of hearts, diamonds, clubs, and spades. Okay, plus, in my 52 cards, how many are diamonds? 13, because there's 4 suits. 52 divided by 4 is 13. Minus, how many cards are a king of diamonds? 1. And I have to subtract that 1 because I counted that guy with the diamonds and with the kings. So then, 4 plus 13 is 17 minus 1. 16 out of 52, or what's that turn out to be? 3077?
Yeah.
And you're also welcome to give me fractions in lowest terms, I don't care.
They're easier than like the next one is like married and not married.
Let's try some more. The next one I gave you a table to read. So, this is showing marital status. So we have males, females, and different marital status. Determine the probability that a resident is male. If I'm going to find probabilities out of this, what am I going to have to do first?
I'm all up, sorry.
Okay. So, here, you guys add up all the females, you guys add up all the males, figure out how many we have.
128.
Females, you said 128.8? And males. So if I want the probability of being a male, there are 122.5 males out of what?
251.3.
Okay, we have to add both of those together, so our grand total. 251.3. We get 4875. Alright, determine the probability a resident is widowed. So it's, my total is still the 251.3. The top, I want the widowed. So we need to add male and female together here. Determine the probability a resident is widowed or divorced. Can you be both? Can you be, well, I think this is going with most recent marital status. So you could have been married, widowed, remarried, and then got divorced. But this is going with your most recent. So could a person fit in both categories if we're doing that?
No.
No. So all we have to do is add them up. Probability of the widowed plus the probability of divorce. Okay, widowed, we've already calculated it, or we could rewrite it. 14.3 out of 251.3 plus divorced. So if I add my divorced people, we get 0.158. Now, did we have to write it out with that formula? No. Could you have just went to your table and said, okay, I need everybody that's either widowed or divorced, so I'm going to add these four numbers together. Absolutely. Okay. Multiple ways of writing it out, but we get the same answer at the end. Is that one okay? Alright, the last one. Determine the probability that a resident is male or widowed. Can you be both?
Yes.
Yes. So we have to do it one of two ways. We either have to use the formula, or we just have to go to our table and add up everybody that fits. Which way do you guys want to try it? Okay. So, because you can be in both groups, we have to say, okay, that means you could be male, or means add, could be a widow. But we know there's overlap, so we have to subtract off the people that are both, that we double count. So our males, we already did that in part A. You could use the decimals or the fraction, either way. So 122.5 out my total. My widowed, we did in part B, that was the 14.3 out of everybody. Minus the people we double counted. We have counted the male widowed in both groups, so we need to subtract off the 3.1. Does everyone know where these numbers came from? How are we doing with these probabilities so far? So or just means add them up, but we have to watch if we double count, we need to subtract those people off. The second thing that we have to talk about today is the complement. The complement is the opposite of something. So if I'm talking about in our high school, okay, you could be a senior, or the complement, the opposite of a senior is, well, everybody has to fit somewhere. So either you're a senior or you're not.
Oh.
Okay, you're a freshman, sophomore, junior. So you can't be in both sets. The opposite of senior is everybody else. Okay? The complement is, sometimes we can see it denoted different ways. So sometimes you see like a little superscript of a C. A lot of times also you'll see it with just a bar over the top. That's meaning the opposite. So the opposite of everything is just 1 minus. Okay, if I want to find the probability of not being a senior, it's just 1 minus the probability that you are a senior. Because everybody fits in one of the two groups. Alright, so, for example, according to the American Veterinary Medical Association, 31.6 of American households own a dog. What's the probability that a randomly selected household does not own a dog? Can you be both own a dog and not own a dog? No, they are total opposites. So we just have to do 1 minus 31.6 would be 0.316.
684.
0.684.
Can you do 100 minus?
Yes, you could do 100 minus, and if you want to tell me 68.4%, that's fine. I would take either one of those. This data gives us the travel time to work for residents of Hartford County, Connecticut. What is the probability a randomly selected resident has a travel time of 90 or more minutes? So 90 or more, that's this, the 4895, but what do I have to divide it by? The sum, so we have to add all these up. You guys get 393,186 for everyone. So then we just divide. So the probability of 90 or more minutes is 0.0124. So B, compute the probability that a resident will have a commute time less than 90 minutes. So I could say, well, if you're less than 90, you're one of these people, and I could add all those up, but what's the easier option?
Just subtract 4895 from the 390.
If you're less than 90, then it's everybody except those, so couldn't I just do 1 minus the probability I found in part A?
Yes.
Because they're opposites. Any questions on these? The last thing I'm going to do is really just practice using the formulas and strictly using the formulas. I'm not even giving you the actual scenario, what these things stand for. I'm just giving you like this notation. Okay. So, if the probability of A is 0.4, probability of B is 0.5, and the probability of A and B is 0.1, find the probability of A or B. That sounds like a lot, but look at your formula sheet. Okay? I need an A or B. So if I look under chapter 5, the first two bullets, I have, or first and last one I found, I have probability of E or F. If they're disjoint, that means nothing in common. Are these disjoint? Disjoint means they can't both happen. So if I have something here, it's not disjoint, because a tenth of the time you were in both. So we just need to go down the bottom. We're basically looking for the formula that has the things we have. So the probability of E or F, just change those to A's and B's. So the probability of A or B is probability of A plus probability of B minus probability of A and B. And sub in what we have. We don't know the probability of A or B. Probability of A is 0.4. Probability of B, 0.5. Minus probability of A and B is 0.1. And what do we get?
0.8. You need to write probably A and B.
You don't have to. Alright. So next one. I still have all the same things. A's, B's, A or B, A and B. So I'm still using the same formula. But we just have to solve for something different. So I'm writing my formula out. What is the probability of A or B? Oh, that was from part A. Sorry. Let's do a new question. Just from this one. 0.7. Okay. And this one, what's the probability of A?
0.4,
Probability of B?
0.5.
And I don't know the probability of A and B. So it's just like solving an equation. Okay, you combine like terms. If I subtract over my 0.9, I get negative 0.2 equals a negative probability of A and B. So what would you do?
What about -1?
Divide by -1 and we get 0.2.
Can you still do that? You just rearrange it because addition is just like switch the and and the or.
Yep. Alright, last one. So, same formula. Probability of A or B. You don't have to write the formula every time, but it can be helpful. So we plug in what we have. A or B, I told you, was 0.9. A is 0.4. I don't know B. Minus probability of A and B, 0.1. So combine like terms. 0.4 minus 0.1 is 0.3. Subtract that over. Probability B that equals 0.6. Do we need more problems like this? Plugging into our formula and solving? Okay. So you guys have time to work again today. Same rule as yesterday. A lot of these questions say find and interpret the probability. Just find it, you don't have to interpret it. Unless the only thing the question asks is to interpret.